Hi there, I'm Kevin Smith, advanced student at Learning Alias, and I wish to talk about a topic, in this case the atomic bomb fillet. And it's a pretty popular technique to handle corners and to round them off in a way that's fairly smooth in hybrid solid surface modelers such as Catia or SolidWorks. If I put off the wires, you can see it's really not very smooth at all. The highlight basically breaks up and follows a V pattern. So a way to handle this would be to do it like this. So basically you blow away the problem area, which was the corner, and you replace it with this big patch, and then you use fill surface to fill it up. In this case, the boundary conditions are curvature continuity, and sometimes it goes a little crazy. Now this one looks pretty good. So you can see it's really quite smooth. It's much better than the default that Catia produces. Now sometimes this can go a little weird, so I have a screenshot of that. And you can see all these pits and valleys. Maybe the hole you punched into it was a little bit bigger or a little bit smaller, or you have an extra edge, or the edge is too short, or the edge is too long. Whatever. It can definitely be a very touchy-feely algorithm, this fill feature. But this one looks pretty good, so if in Catia I throw on a material, I won't go for the metallic kind of thing, but I'll just go for a fairly shiny white. You can see that the highlight is pretty nice on there. You can see that, the flow is nice and smooth. And really, not too much to talk back to. If we go to the original, this was the original. You can see very, very ugly looking transition. So for consumer product design, I think the atomic bomb fillet is a technique you could definitely use. It gives you a nice, fairly smooth region or a highlight, and it's a fairly fast and quick technique to do. However, what I want to show here is that this does not work for automotive. Maybe an automotive interior, dashboard or panel, great, you could still do this. Perhaps after you've transferred it to a system like Catia or NX. But for exterior panels, this isn't going to fly because the highlights are good, but they do break down. So if I export this to a step file, and I have already done this, and I go into Alias, and I open her up, I'm going to show you just how much it breaks down. I'll accept whatever tolerances this file has, and it will probably come in as a stitched model, which is alright. So you can see it's a very heavy patch. I'm probably going to select the object and go to Surface Edit, Unstitch, hide all the controls, and basically reshade it up. So this way you can see this is a surface 5x5. So the fill surface in SolidWorks as well as Catia, I'm not sure about NX, is a degree 5 surface, but you see it has a lot of spans. And now if you look at the CV hulls though, they're fairly well behaved. Let's go into wireframe on this whole thing and turn off the grid. I'll re-highlight it. So you can see that the CVs, there's a whole lot of them, but there's not any sudden peaks or valleys in the structure of the CVs. Notice the horizon as I tumble. You can see it's pretty well behaved. So despite it being a very complex patch, it's not that bad. However, you can't really adjust this in any way. And the problem is the highlight isn't good enough, so you would want to adjust it. So if I turn the model off, I'm just doing the regular showroom type shader. You can see that it will break down. So if I go to a slightly lower tolerance, you can see a problem in this region. As I roll the highlight across, there seems to be a little kink or dip, which is not so nice. Then here the bottom is pretty okay. Then here as well in this region is a pretty sharp transition. Though of course the fillet, the small little fillet here, wasn't curvature continuous. It was actually a row or conic-like fillet. So if I select these two planar surfaces as well, so I'm going to go to the dynamic section tool, and this will work just fine. You can see what kind of fillet it is. It's not a circle because it has acceleration, but the connection here is not smooth. Maybe I could have done that and gotten a slightly better result in Catia. But you look at this problem right here in the corner, and you can see a little problem. Now, of course, this big patch to all of the edges it adjoins has a curvature continuous constraint put on it in Catia. So the fact that this patch is not curvature continuous, I'm going to try making the bases here of these fillets curvature continuous, and we'll see what it gives me. The big patches are planar, so they don't have any acceleration to them, but I can make sure that the rate of change on my fillet starts off at basically 0. Not sure if that will give me a much nicer result because, you know. But you can see that it's really not a bad thing, but especially from like a point of view of this, you can see it's, I don't know, the highlight's a little wobbly, and, you know, like this region looks a little chewed up, this region looks a little pinched up. You know, for consumer product design, that's kind of more like this, you know, kind of like maybe a fairly somewhat shiny plastic, you know, with a little bit of a diffuse specular highlight going on. It gives you great results. So for consumer product design, yes, 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 the atomic bomb fillet is a great technique. And I really think Alias should improve their end-sided surface tool, which is located under Surfaces, end-sided. You know, the guy should really work on this a little bit more, and you could get the same kind of thing. Maybe not for exteriors, but for interiors, I think it can definitely help. If I go to double horizon, just to finish it off here, so I think I'll leave it at this. The atomic bomb fillet, very interesting technique, and I hope you enjoyed it a little bit. Cheers.